Numericals on lens makers formula. Question number 1. The radius of curvature of each surface of a biconcave lens made up of a glass of refractive index 1.5 is 30 centimeter. Find the focal length of the lens in air. Let's write the information. So we are given mu equal to 1.5 R1, radius of curvature of first surface will be negative. So it is minus 30 cm. R2 for this surface, it will be positive. It is also 30 centimeter. Then we can apply lens maker's formula. 1 upon F equal to mu minus 1 upon R1 minus 1 upon R2. So we put the values 1.5 minus 1 times 1 upon minus 30, and this will become also 1 upon minus 30. So 0.5 multiplied by minus 2 upon 30, which will become minus 1 upon 30. Hence, F will be minus 30 centimeter. Consider question number 2. A biconvex lens has focal length 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of the lens material. So here, this is biconvex lens, and R1 will be positive, say plus R, and R2 for second surface, it will be negative, minus R. But in our question says a biconvex lens has a focal length 2/3 times the radius of curvature of either surface. Calculate the refractive index of the lens material. So here, focal length F is equal to 2 by 3 of radius of curvature. Now we can apply lens maker's formula. So 1 upon F equal to mu minus 1 upon R1 minus 1 upon R2. So F is equal to 2 by 3R, that is 3 by 2 R equal to mu minus 1 upon R plus 1 upon R. 3 by 2 R equals mu minus 1 times this R is in denominator, 2 by R. So this R will cancel out, and we will get this 2 will shift to denominator. So mu minus 1 equal to 3 by 4. So now 1 can be shifted to RHS. From here, mu will be equal to 1 plus 3 by 4 is 0.75. Hence, mu equal to 1.75. Let's go to next question. Question number 3 says, find the radius of curvature of the convex surface of plano convex lens whose focal length is 0.3 meter and refractive index of material of the lens is 1.5. So first let's draw the diagram. So this is plano convex lens. We can write the information R1 for plane surface, since focal length is infinity. So R1 will be infinity. R2 will be, say, negative R. Now we use lens maker's formula. Formula is 1 upon f equal to mu minus 1 upon r1 minus 1 upon r2. Here focal length is given as 0.3 meter. So 1 upon 0.3 equal to mu is 1.5. So 1.5 minus 1 times 1 upon infinity minus, so this minus will make it positive, 1 upon r. So this will become 10 by 3 equal to 0.5 divided by r. 1 upon infinity is 0. So 10r equal to 1.5. So r equal to 1.5 divided by 10, that is 0.15 meter or 15 centimeter. Let's go to next question. A convex lens of focal length 0.2 meter and made of glass having a refractive index 1.5 is immersed in water, mu equal to 1.33. Find the change in focal length of the lens. So 1 upon f, focal length of lens in air, is equal to mu minus 1 upon r1 minus 1 upon r2. So it is 0.2 meter and mu is also given 1.5. So we can put the values. 0.2 equal to 1.5 times 1 upon r1 minus 1 upon r2. So from here, this will become 3 by 2, and then we can shift this to LHS. So this will become 1 upon, this will become 2 by 10, and this will become 3 by 2. So 2 by 3. Sorry, there is a mistake. It should have been 1.5 minus 1 upon r1 minus 1 upon r2. So 1 upon 0.2 equal to 0.5 times 1 upon r1 minus 1 upon r2. So we can shift this here in denominator. So it will become 1 upon 0.2 into 0.5 equal to 1 upon r1 minus 1 upon r2. If we simplify 100 by 10, so we will get 10 equal to 1 upon r1 minus 1 upon r2. Suppose this is equation number 1. Now, for the same lens in water, suppose new focal length is fw. So here we have to write a relative refractive index, that is 1.5 divided by 1.33 minus 1 times 1 upon r1 minus 1 upon r2. We can put the value of 1 upon r1 minus 1 upon r2. So this will become 1.5 minus 1.33 divided by 1.33 times 10, 1 upon fw. So it will become 0.17 into 10 divided by 1.33, 1 upon fw. So fw will be equal to 133 divided by 170, that is 0.78 meters. Now change in focal length, change in f equal to fw minus f air So FW we have got 0.78 and F air is given as 0.2. So it will be 0.58 meter. Now let's go to next question. Question number 5. An equiconvex lens of focal length 15 centimeter is cut into two equal halves as shown. What is the focal length of each part? So here R1 will be plus R and R2 equal to minus R. Then from lens maker formula, 1 upon F equal to mu minus 1 upon R1 plus 1 upon R2. So here R1, R2 both are R. One is positive, another negative. So we write here 1 upon R. So it will become 2 upon R times mu minus 1. So 2 times mu minus 1 upon R. Suppose this is equation number 1. Now for each half length, R1 equal to R for this one, but R2 will become infinity because this line we will consider this is plane surface, and for plane surface or plane mirror, the radius of curvature is infinity or focal length is infinity. So radius of curvature will also be infinity, but this time this will be taken as negative because this is positive. So this must be negative. So we find out the value of F. 1 upon F equal to mu minus 1, then 1 upon R minus 1 upon minus infinity will give mu minus 1 upon R. Now let's relate. Suppose we write it as F1 because this is F. And now if we divide 1 by 2, dividing equation 1 by equation 2. So 1 upon F divided by 1 upon F1 will be equal to 2 mu minus 1 divided by R multiplied by R divided by mu minus 1. So from here we get F1 upon F equal to mu minus 1, mu minus will cancel, R will cancel. So it is 2. So F1 equal to 2F. But F is given as 15 centimeter. So F1 will be equal to 2 into 15, that is 30 centimeter. Which is our answer. Thank you for watching.